closing remarks given by Pål Elfsing from Vattenfall. So, Pål, please, stage is yours.
Hey, thank you very much. I do recognize that I got some extra spare time here, which I'm pretty happy about, because those who know me know that I can talk for a long time sometimes when I get sort of agitated about something. And so please don't feel depressed if you need to push me on. But I agreed to take a set of sort of making some closing remarks of this. It's quite difficult to sort of try to condense what we've heard today, because I think it's been a number of very good presentations, and I would like to thank the presenters, obviously, for that. I would also like to thank Monica and Pasi for setting the workshop up. I think it's a very good initiative, and I hope that we will sort of afterwards can agree that this has sort of set us on a stage where we at least know where we have each other. And I think that's a good way to start, because a lot of good research is done by collaborative work. I would also like to extend a thank you to all of the participants. I think Monica said that there were 83 registered participants, which I think is a great outcome of something like this. And perhaps that's the great benefit of having meetings online, because you can actually have a possibility to get people that perhaps normally would not travel or couldn't have the opportunity to travel to participate in meetings like this. I could perhaps have been a good charm this time from that perspective. And I obviously especially like to thank those of you who are in different time zones. And I'm not specifically speaking about the difference in Sweden and Finland, which is an hour in the time zones, but there are people sitting way out there, and I recognize that some of you got a very early morning, including you, Meg, here. It is still sort of morning in your time, but Matt proved that he was awake at 5 minutes to 6 local time. So I highly appreciate that. My thinking about how do I sort of connect this, I thought, hey, okay, let's see what do we do? How do we Ringhals act in this perspective? And interestingly enough, when I breeze through the few slides that I put together with the help of specifically Björn Forsgren, but as you can see, we're a full team working in this area, including persons from the management team. Henrik Lidberg is our R&D manager, so he's the guy in charge of the money side. And they are very much focusing on this as an opportunity. It's a possibility to increase the future for us. It's very much needed. This is not something that is just happening on the engineering side of the world, but this is actually happening in the plant side of the world also. And I think it's quite important to see that. And as you will see, most of these issues that I bring up has been brought up by one or two or several different presenters already. And I think it just will try to connect some of the dots here and perhaps end up with a few final thoughts from my side. Well, why do we, as the nuclear operators, look at additive manufacturing or powder metallurgy? I think Meg clearly pointed that out, that we're not just looking at additive manufacturing, but it is in fact powder metallurgy that we're looking at. And not only that, we should include other areas which are adjacent technologies, such as electron beam welding and cold spray, which are sort of similar technologies from many points of view. Obviously, there is the economical crunch that we're all seeing and feeling. There is a huge change in how the electricity grid is operated for the moment, where you have a pronounced incoming renewable fleet, which are favored above baseload production at this point, and that makes it more difficult for us to be at the grid when we are needed and to be at the grid enough to make money. So in our side, we are sort of fighting something we call the 2 cent per kilowatt hour, which is a fairly low price of production when you come to nuclear power, knowing that just a few years ago, most nuclear power plants in the world were happy if they were below 3 cents per kilowatt hour in production price. But we need that to be economically relevant to stay on the grid. And this is something that you can compare to the nuclear promise in the US. Our US participants, they're very well aware of that from the US industry. So it's a similar way of looking at it. Obviously, aging plants needs new challenges. And from that perspective, I think it's something we all understand, that we need to be moving outside our comfort zone. We have a possibility that we have an inability to sustain spare parts in-house or deliveries at acceptable cost and time, and that was clearly pointed out by Steve in their component that they built for the Belgian power plants, which I thought was an excellent piece of work from my perspective. You also should keep in mind that not all countries have a licensing period. If you look at Sweden, for example, we don't have a specific licensing period. We have a PSR, periodic safety review scope, and we also have an acceptance for a continuous regulatory drift. And I think by that, you should also keep in mind that even though we are trying to squeeze our costs, that should be done in a capability where we at least retain, but more likely improve our relative nuclear safety. So it's continuous improvement, and this could be a possibility to maintain that and to push this forward. From that perspective, we need to take some strategic choices of what and whom to rely on and whom to turn to when we need technical expertise, as well as whom do we rely on for spare parts. And that's what's been clearly pointed out by a number of participants today, that is the obsolescence issue is something that we really need to deal with. In this context, you can also keep in mind that when you look at a nuclear power plant, I think there's approximately 5 million components in a nuclear power plant. And not all of them obviously are critical or safety related, but there are plenty of components which are, but there still are many components that we can deal with, and many of those can most likely be replaced by other means of manufacturing than the traditional. And also keep in mind that perhaps the most optimized component is the one that we can keep in the plant rather than exchanging it. So we have to keep that into our heads also when we deal with maintenance and how we sort of put up our maintenance. From this perspective, we have envisaged something that we call the virtual warehouse. That is sort of our way of dealing with how can we deal with times to come when we see an increased obsolescence issue, where we see an increased or a decrease in the number of available manufacturers, because that's also something that we do see now, that many of those components that were manufactured in the 70s, in the 80s, there simply aren't any manufacturers left that makes them. And if there are, they might have moved on and left the nuclear area, or they have no interest in providing us with components, or they have enormous amounts of time before they can deliver. And obviously, for that to happen, we need to be smarter. We need to be more cost efficient in our maintenance work. So that's one of the benefits of what we're looking at. The second objective that we could be looking at would be shorten the time from issue to solution. And again, Steve pointed that very clearly out, that we're talking about days rather than weeks when you see something. And from that, we also need to include improved maintenance procedures and trending. And that was something that was brought up from the very beginning. I think it was Siemens who brought up the possibility to be smarter when it comes to replacement of components, and sort of show the benefit of the entire both manufacturing and repair, and optimize the supply chain. Obviously, the goal for us is to have a fully digitized tool for the plant staff to allow us for automated component status and replacement and trending and spare part ordering. And from this, you need to sort of have a number of issues that you need to deal with. But one thing that I think has also been brought up a number of times today is the need and the wish to avoid some nuclear specifics when they are not needed. There are areas when it comes to nuclear safety where we do definitely need to have a very, very clear view on that we have nuclear regulatory guidance that we need to fulfill. But there are areas in the nuclear power plants which are not affected by specifically being a nuclear power plant, but could be any power plant. And we need from an industry to be able to implement industry standards when that is applicable. Already touch upon this, that the that we're not just looking at additive manufacturing, we're looking at, from our point of view, powder metallurgy and additive manufacturing as one set. And as already Meg pointed out, it was very clearly that there are other components or other technologies that we can introduce into this. The obvious and apparent benefit of this is the possibility to include reversed engineering, to sort of take a look at what kind of a component do we have and sort of backwards engineer it to something which is possible for us to make sure that we can replace components when they're needed. We also need to understand that if we have a design-driven manufacturing, which was brought up by several presenters earlier today, we may have fewer design limits. And I think from that specific point, it was very interesting to hear from Etteplan and Erin when she was talking about the support structure, that we also need to analyze the support structure to make sure that we know what we are producing. And I think it's very wise and very smart to bring that up from the very beginning. And again, the obvious areas of interest would be to have a possibility to have a digital archive for spare parts. We have a possibility to avoid obsolescence. We have a possibility to make tools which we cannot make by other means. That was pointed out earlier also, that there are a number of ISI equipment components that perhaps cannot be made because you simply don't know what it looks like when you're going there. So this is a possibility to make that sort of shortcut in that perspective. And you also obviously need to see if there is a possibility to include repair technologies in this context. So from our point, we have sort of adopted a additive manufacturing strategy, which has a number of steps that we have been looking at. In this case, I think we have demonstrated 6 different steps, and it all starts out with the awareness, learning the trade, learning the processes, which processes are there, when are they applicable, what advantages and what disadvantages do you have, what constraints, opportunities, limitations. And also, are there any given manufacturers that can help out in this case? Because again, we need to make sure that we bring in the best competence available, and not every good competence is born inside your own walls of your company, because most often there are several other companies that can help you out in this case. And in our case, we have decided to have a very close relationship with EPRI. Vattenfall is a full member of EPRI, and for that matter, we have sort of started a discussion on the possibility to include our additive manufacturing work with their additive manufacturing work to avoid double work. Obviously, you need to look at material qualification. We have, as many others, started out with 316L. The reason for that is that it's an area where you have a huge money savings to foresee. Dino pointed that out also, that's where the money are, and that's where you should sort of focus your points. And obviously you need to understand not only the manufacturing portion, but also the post-manufacturing processes that you sort of need to apply to be able to have a component that you can use in a nuclear power plant, including quality assurance, which Alejandro pointed out very clearly today. In our case, we settled down at the SLM process. The main reason for that is that it was applicable for us when it came to the needs we had and the components we were looking at. No other specific connections to that. I mean, we could have chosen almost any process, but this was the one chosen as the most favorable one for us. After you have chosen a process and you have chosen a component that you want to look at, you should try to find a demonstrator, and that was clearly pointed out by Stuck, that you need to have something that you can have a proof of concept that this actually works. And I think I strongly agree with that. It's very important. And obviously, when you look at that, you should look at components which are of importance for you. You shouldn't look at components which you can easily and readily find from many different vendors, because that's not a point here. The point here is to find the components which are unique, meaning that we lose time, we lose money every time we have issues with it. And obviously, the last step, again, it's the qualification process, which I will come back to. From us, we have looked upon a number of sample objects and what kind of requirements we should put on them, geometrical tolerances, mechanical properties, the chemical composition that we need. It was pointed out very clearly earlier also that I think it was Steve who brought that up, that don't just look on the chemical composition as it said in the ASTM standard or some European standard, but you also need to understand that there are other chemical requirements that come up, and one of those would be oxidized powder. For example, the oxygen layer that you may have on the powder that may or may not influence corrosion resistance or your aging behavior. You need to understand what kind of a post-heat treatment you need to put on. It was brought up by Quintus, by Hans, that there are possibilities to work with that, and in some cases you can actually have a significantly improved component or product after your post-manufacturing handling. So from this, if I have sort of slightly changed this from the view graphs that I sent to Jonathan earlier today after listening to some of the presentations, because I thought it was really neat. Step one, obviously, is the development of relevant code cases. And I think it's one thing that hasn't been pointed out when we've been discussing about the code case N834, which is now accepted by the NRC, is that is sort of the model, the role model of the additive manufacturing code case, which is now being pushed through the ASME code. And I think it's important to understand that we're not specifically trotting a new route. This is something that has been accepted, and I think it's very important from that perspective. And also in that perspective, please keep in mind that we are comparing to forgings and not specifically welds, which means that you have other issues that you need to take into account when you are sort of qualifying your component. Step number two is obviously the regulatory acceptance, and I was very happy to hear that the NRC has been very proactive in this matter and already started and really work on this side to make sure that we can gain some sort of acceptance for the proposed methodology and also acceptance for the results. And I do believe that most of the European regulatory commissions, they are following the work very closely. And I think that could be very interesting for the future. But obviously, we also need to make sure that the standardization, either it's the ASTM or the ASME or the RCCM or the Eurocode, we need to make sure that that harmonizes with the steps that we're taking right now. So it's important that we take our time and make sure that those groups understand our needs. And the two final steps would obviously be plant qualification, where you start out looking at the possibility that we have a material which can be have a proven long-term applicability and resistance both to aging and degradation, what we call applicability qualification. I think that's ongoing work in many areas right now, that you need to understand what kind of degradation mechanisms are active on these components and how do the component themselves or the material behave from that perspective. And after that, you need to go for real component testing and include to that a structural assessment of the component, meaning that you need to take into account, for example, fatigue behavior, which have been discussed today also. And to sort of try to conclude from my perspective, I think that it's important to realize that this, as many, aren't purely driven by the end users, but we have the need, and there are others that have the means. And I think it's and the manufacturers need to push ahead and to make sure that we as end users are given the right tools to work with. And I think that today has proven that there are much ongoing work that sort of points in this direction. I'm really happy for that. In our case at Ringhouse, we have taken a deliberate step to work with a couple of Swedish research companies, in particular Sverim and RISE, to find the ways forward, and those include also powder manufacturers to understand the base material, which has also been pointed out here, that how important that is to understand, because we need to be accountable. We need to be able to reproduce our results. If we cannot reproduce, then it's not a route forward, and that's very, very clearly. And as I said, we've also started out working together with EPRI, and we have other ongoing discussions with other companies and institutes to sort of bring those in to work with us instead of against us. And I think that's quite an important thing, that we're all sitting in the same boat. We need to be heading in the same direction and make sure that we put up some speed here. And from that perspective, I think that it's important to realize that a plant engineer has a number of issues that they need to address, and that could be including like inspection, structural integrity, aging, degradation, irradiation resistance, fatigue issues, surface fineness, which may lead to activity buildup and stuff like that. And I think that all of these areas need to be addressed to be able to push forward from this perspective. And by this, I would like to open up for a possibility to ask questions. And if you don't have any specific right now, I think there would be a possibility when Pasi and Monica has finalized the symposium itself.
So thank you very much, Paul. I think you summarized the kind of outcome of this webinar very nicely, and kind of highlighted different viewpoints. One thing that I kind of recognize from your presentation, that of course there is a lot of a kind of nuclear specific topics like an irradiation and the safety codes, but then there are many others which are not that nuclear specific. So maybe we could learn more from the other industries, because a lot of research and the development is done in this field also in the other industries. So one thing to keep in mind. There seems to be one question for you, Paul. What do you think is the single biggest challenge related to implementation? Is it the current lack of standardization, or particularly technical aspects of different techniques, or something different?
I think that the lack of a standardization process is perhaps the biggest obstacle that we need to look into, because there are many smaller trapdoors that we need to be aware of. But those are sort of reasonably well handled if we are smart enough. But if we don't have a standardization process, and if that standardization process perhaps is not specifically relating to the power plant wherever it stands, because my power plant at the west coast of Sweden do see the same kind of environment as many of the power plants in Finland, and in many of the power plants in the US and in France and Korea and Japan. They simply don't care about what kind of language we speak outside. They react to what kind of environment they're working in, and it's very many similarities between the countries. So if we don't have a collective view on how to standardize, I think we're going to be in big trouble. So I think that's definitely the key area here, to make sure that we're smart enough to. Now we have sort of singled out that issue. We should try to sort it out also.
Yeah, and I mean, it's also good to notice that there are activities towards the standardization, so there is progress going on. So that's really great. Seems to be that there isn't any other questions from the audience. So I would like to thank you, Paul. Really nice summary you made. And Monica, would you join to close this webinar?
Yes, I think that we've had a lot of inspirational presentations, and yes, of course, there are challenges. But I think that in the near future, this will be an important part of daily life at the plants. And when I hear this kind of inspirational presentations, I feel that I just love being an engineer, because it's so much interesting new technology that's coming. And I would like to thank all the speakers and also you participants, and especially the participants that were brave enough to be active in discussions and asking questions. And I really hope that you've all made some new contacts today. We will publish the majority of the presentations and also some of the videos and you will receive a link by email as soon as that is up and running. And there are 2 teams discussions left for today. And one of them is if you want to discuss more with the Ulrik at BBN Components, the link is in the chat box. Or if you want to join, like we have like a general after webinar Mingle that's hosted by Pål Elfsing. So this is like, you know, when you finalize the seminar and you turn to the people next to you and you sort of digest what's been said during the day and discuss things. So that's sort of the discussion that we're expecting. So anything from discussing individual presentations to additive manufacturing in general, or simply just having an after office chat. So most welcome to join that discussion, and the link is in the chat box. Thank you very much, everybody.
Also, on my behalf, I would like to thank you, all the speakers, with very nice presentation, and then audience being active and asking questions. So that's the really way to go forward with this topic. So thank you.